we're given a differential equation and we must ultimately solve it. But they're giving us a two-step problem here. They're sort of guiding us in. They're saying use this substitution, which tells us that we're dealing with homogeneous equations, to show this. So let's use this substitution. How do we use homogeneous equations? If y is equal to vx, then dy dx is equal to, now we get first times derivative of the second, which is 1, plus second times derivative of the first. This is just merely chain rule. And now we're going to be using this equation and substituting them in here. So let's replace dy dx with what we just got here to get v plus x dv dx is equal to, and now replace all the y's with vx, v squared x squared plus x squared over 2xy, and y, I'm going too quickly, y we have replaced with vx. And essentially you can factor out x squared from here and get rid of it, so this becomes 1, and this x times x is x squared. And then this, what you have now, looks exactly like this. So we have solved part A. We were guided into the problem, basically. We're now in, so this was part A. Of course I forgot to write A, it's right there. Now we're in part B, so we don't really need this anymore, for now, until we progress with the problem a little bit. So what do we do now? We have to put all the v's on the left side and we have to put all the x's on the other side, so that this then becomes a variable separable. And to do that, we look at this equation, so this is what we're dealing with. We multiply both sides by 2v. And when you multiply both sides by 2v, we get 2v squared plus 2vx dv dx is equal to 3v squared plus 1, right? So this is a bit messy, but this is the same as this. Then we subtract 3v squared from both sides to get minus v squared plus 2vx dv dx is equal to 1. Now we use this to then go about to our variable separation process, and if I just move this a little bit, we can work with it on this side here. I add v squared to both sides to get 2v dv dx is equal to 1 plus v squared. Now we divide both sides by v. You can also divide by 2v. Perhaps it's better to divide by 2v actually. So dv dx is equal to 1 plus v squared over 2v. And now we have to separate the variables here, and we do that by multiplying both sides by 2x, and then actually we're going to have to flip the whole thing over. So we multiply, actually we have to divide by dv. Okay, it's a bit more complicated than I thought it was going to be. 1 over dx is equal to 1 plus v squared over 2v times 1 over dv. And if you now flip the whole thing, I'm going to have to push the problem upwards. If you then flip the whole thing around, you get that dx is equal to dv times 2v over 1 plus v squared. Now all we have to do is take the integral of both sides. How do we take the integral of both sides? Pretty easy over here. Did I lost an x in this process? Of course, there's an x that goes here. Sorry, x, 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 and then dx 1 over x. So that becomes ln x plus c is equal to, now we have to take the integral of this. You have to use substitution, and you have to use substitution of u is equal to 1 plus v squared, and then the derivative of that will be 2v, which will cancel out with this 2v, and then you will be left with ln of 1 plus v squared, right? We already have our constant, so you don't have to put another one on the other side. Now, if we go back to the problem, which I have hidden, we get that we need to solve the equation given that y is 2 when x is 1. So, from this it follows that when x is 1, and x is 1, y is 2. Now, notice that we don't have a y because we have a v. So we go back here and we say that since y is equal to vx, then v must be equal to y over x. Hence, in here we put ln of 1 plus y squared over x squared, conveniently. This then, if you put in, we said we're going to put in y is 2 when x is 1, you get ln of 1 is obviously 0, and so you get that, you can't even see this, that c is equal to ln of, I forgot again, y is 2 when x is 1, ln of 5. And so, the answer to our equation is going to be ln x plus ln 5 is equal to ln of 1 plus y squared over x squared. If you were to manipulate this around, you would get that y is equal to plus or minus x square root of 5x minus 1. All you have to do is say that this is equal to, okay, ln of 5x, and then this is equal to ln of 1 plus y squared over x squared. When you divide some stuff over, when you work left, work right, and take the square root, you will get square root of x squared and then square root of 5x minus 1. So this is your answer. This is what the differential equation looks like. So when you take the derivative of this, you would get this up here. That's your answer, right here.